Howdy folks, welcome back for another Feature Friday. I'm your host Ryan Glover, and this week we're going to talk about inline editing. So this may not be immediately clear, so what I wanted to do to get started is show you what exactly I'm talking about. So Command, the product that I've been working on through this Feature Friday series, I think I started with it, or it was the first few videos, but the product that I've been working on, Command, is now in private beta. And with the few users that I've onboarded already, one of the big pieces of feedback was a part of this requirements list. So people were really enjoying being able to add requirements to a card, but what they were having trouble with is once they added them, they couldn't edit them. So if you had a typo or something like that, you had to delete the whole thing, go back and fill it out again. So this week, one of the things that I worked on was making all of these requirements editable. So we can see here that I've got a requirement and I can check it off. And before, I couldn't actually do this. So now I can go and I can click on an existing requirement in my list and I can say make some change to it, hit enter, and it updates. And then we can also see that that stores itself in the database. So it's both updating in real time on the client side in state as well as in the database. And this seemed like a really good video to do because at the heart of this, the actual interaction is quite simple, but this is one of those things that unless you've done it before, it may not be immediately clear how exactly you put that together. So what we're going to do is jump over to the code, and this is what's actually rendering this list. So you can see here I've got quite a few different things going on, but the important part to pay attention to is this.state.requirements. So when somebody adds a new requirement to their list, it's added to state, and then that state value is rendered down here. So when I say down here, this.state requirements, this whole loop is generating what we see here. So if I will say add another item and one more just because. So these three items are being rendered by this code right here. And so the idea is that we're taking this.state requirements, and you can more or less ignore this sort by. So this is specific to this application. I just want stuff to be sorted by the drag and drop order. So these requirements can be moved up and down. So I'm just forcing the order at that point when I render them. But the important part here is the this.state requirements being passed to a .map function. So we're going to loop over each of the items in the requirements array, or this.state requirements array, and we're going to put something on screen or render something to the screen when that happens. So inside of the function body, so right here, we can see that we have a component called requirement, and this is just a style component that adds some CSS to handle all the positioning here. So this makes sure that the checkbox is on the left, the text is in the middle, and then the remove button over here is over on the right. So inside of that is the important part. So we've got our checkbox, and then we've got the logic to actually handle this inline editing. So before we look at the editing itself, what I want to talk about is, well, how do we get to an editing state? Because the thing you want to keep in mind is that all we're really doing here is just shifting between two states. We're not really changing the UI in any fundamental way. And so because we know we're changing between two states, so it's a binary thing. It's either this or it's that. And so we can see that kind of logic playing out here. So if you're familiar with a ternary operator, you'll start to understand this very quickly. So we're saying, if this is true, do this, otherwise do this. And so the otherwise in this case is our default state. So the default state is that you are not editing an item. So when I click in, that's when I'm editing an item. But the question is, well, how do we get to that other state? So let me show you. So what we're going to do is say, okay, if we're not currently editing an ID, and if we look, ID is the current ID of the item or the requirement that we're currently looping over inside of this.state requirements. And that's important. So we're not going to call much attention to that just yet, but just know that in this instance, we're not currently editing that specific requirement. And so what we're going to do is we're going to render this span tag, which is actually responsible for rendering the requirement text. So quite literally, whatever we type in here, and I'll say whatever we type in here, this span right here, this text right here, is what this span is putting onto screen. And we can see that getting to the editing state is actually quite simple when it comes to the code. So what I've done is I've added an onClick handler to the span tag that's wrapping that requirement text. So this whole line, and I've done some CSS behind the scenes to make sure that the span tag is display block, which means it fills up the entire width of its parent. So what I mean by that is by default, span tags are known as inline elements in CSS, meaning they only take up the amount of space that their content allows. So literally, without my CSS, the width of this span would stop at the end of this E character right here. But with a little bit of CSS, if I say display block, it forces the width of that span tag to take up the whole row. So it doesn't matter if I click over here or if I click directly on the text, it's going to trigger that call to onClick. So back here, if we take a look at what the onClick is doing, what I'm saying is, well, we need a way to know which one we're editing. And I say which one because we could potentially have tons of requirements. So here we just have 4, but it could be anywhere from 1 to 500. That might get a little overwhelming in your day-to-day work, but it is feasible, so we have to kind of account for that. And the other thing we want to keep in mind is, well, you're not really going to want to have a bunch of editing boxes on screen. So we want to be able to toggle between 2 items in the list, or rather said, we want to toggle the editing state between 2 items at the same time. So if we look here, and one more just because is the one that I'm currently editing, but if I click down here, we'll notice that goes away and I get this one. Click up here and now they just flip. So in order to achieve that, what's going on here is we're saying on to state, we want to tell ourselves which requirement we're currently editing. And like we saw just a little bit ago, where we're taking the ID here to decide whether or not we're editing, that's the same exact ID coming from the requirement itself. So this is the ID from the database. So we're saying take that ID and set that onto state as the editing value. So because we're doing it this way, what we're saying effectively is that editing or this.state.editing can only ever be one ID at a time. So we're not saying editing could be multiple IDs at once or anything like that. We're always saying it can only be one. And so what we know by that, at the very least, is that, okay, well, in theory, only one of these can be in its editing state. In theory. And I say in theory because we have to still write the logic to make that happen. So, and we'll get to that in a second. So right now, we're just saying, go ahead and set the one that I've clicked on. So the requirement that I've clicked on in the list, and again, we're mapping over a list of requirements. So this could be one or more. And so we're saying, go ahead and set the ID of the one that I clicked on onto this.state.editing. Okay, so that's step 1. And then step 2, and this is a little freaky deaky. So what's going on here on line 149? What we're saying is after we've set that value onto state, we immediately want to focus the editing input that we should have just revealed. And I say should have again because we have to write the logic to reveal an input for the user to edit or type into to edit the requirement. And so you'll notice here that I've got a convention, and we'll start to unpack this very soon here. So what we're saying is find the element on the page with the name attribute equal to editing underscore and then the ID of the requirement that we just clicked on. So we're telling ourselves this is the input that you want to focus into. So we can see here we call the .focus method on the return value of document query selector. So some of you may be wondering, like, isn't that a little dangerous? And it's technically a little dangerous. So in this case, I trust this code. I've tested it pretty well, so I'm not too worried about it. But if you wanted to be a stickler about it, you could say something like editing input and put the query for that selector behind a variable and then say only if you have the editing input do you want to focus it. So I can get away with something like that. And that's really just a guard in case for some reason the timing is off and the editing input doesn't reveal on screen. If we try and call this code, we're not going to accidentally call focus on something that doesn't exist or is undefined. Again, that's a stickler thing. So in this exact instance, I know that it's going to work how I had it, so not going to worry about it. So with all of that in mind, now the question we have to answer is, well, how do we render that input? Like, how does that get on screen? And that comes back to this logic I showed you earlier. So we're saying this.state.editing, or if this.state.editing equals the ID that we're currently looping over. So keep in mind, we're mapping over or looping over a list of requirements. So for each one, what we're doing is we're writing into memory. We're saying, okay, if this case is true, do this instead of this. And what's cool about this, and this is kind of one of the perks of React, is that state triggers a re-render whenever it updates. And so in this case, this is awesome for this type of UI because we want to change how our UI is rendered when this.state.editing changes. And so whichever item in this list, so basically think about it this way. When this page loads up, as we see it right now, so let's do a refresh. So what's going to happen here is, okay, this list was output. So we mapped over everything and rendered the span tag that we saw. So that's the current state. And then as soon as I click, because we had that this.setState editing to the ID that I clicked on, that triggered a re-render, and now every single one of these was put back on a screen, even though we didn't actually see it. This is happening behind the scenes inside of React's virtual DOM. So those were all re-rendered to screen, but this specific item, the one that I clicked on, its ID matched the current value of this state editing. So what that means is that our ternary operator said, oh, I want to return this clause. And this clause, if we look, it's pretty obvious, is an input. And so this input, if we look even closer, has a name attribute of that editing underscore ID. So what we just looked at down here, we're saying we want to focus that input. We can see that we're giving that input when it's on screen a name attribute of editing underscore the ID of what we clicked on. And so the idea is that as soon as this is revealed, we're going to focus it so that the user can start typing immediately. So if I click on this one, we can see that the input lights up. So there's nothing that I have to do. I don't have to click twice to get in there, which is a great UX. So I'm not having to do anything. I could just say whatever, type in here, and start writing something immediately. And I'm done with it, which is pretty neat. So up until this point, that's how we get into our editing state. We say set the ID on state, or this.state.editing, render the input whenever there's a match between this state editing and the ID that we're currently mapping over. And then we get to the next part of this, which is how do we actually make an edit. So up until this point, all we've really done is we've created a UI for us to do the edit, but we haven't written the logic to actually change anything. So if we look down here, I've got 3 different handlers. So these are very, very, very important for how this works. And you'll notice, so I keep doing it, and you might have heard me clacking on my keyboard. So if I say type something, you'll notice that I'm not clicking a button, I'm not doing anything, I'm just hitting the return key on my keyboard. So what I'm doing by doing that is I'm capturing that event and saying whenever I see that specific event, I want to try and close the editing state, or I want to disable the editing state. So the way that this works is pretty interesting. So what we're saying is on key down, if the event key code, and now this is where this gets a little freaky. So event key code is saying whatever event is being passed to on key down. So literally when I press a key down on my keyboard, what we're saying is get that event, and then we're saying look at the key code for that event. So every single key on your keyboard, when you press it, behind the scenes, JavaScript has a specific number or key code for it. And so if I push A, that's going to be a key code. And in this case, if I press enter, and don't ask me why, but the key code for the return key or enter key is 13. So what I'm saying by default is I'm saying, okay, when you're pressing the key down, I just want to prevent default. I don't want anything to happen. I just want to stop. So I don't want to change anything. But I'm going to say on key up, if the event key code is 13, then I want to update the requirement. So what I mean by that is when I press enter and the key pops back up, I want to do 2 things. One is obvious right here, which is I want to trigger an update of that requirement to whatever the change was that the person made. And we can see here that I'm calling to this.handle update requirement, which is another method defined on this component. So this is the requirements component that's rendering this whole list. So when I call that, I'm passing in the event. So this is the onKeyUp event in this case. So I'm passing that raw event along with the underscore ID, so the ID of the requirement that we're making the edit to, or trying to make the edit to. So you'll notice that I'm doing essentially the same exact thing on blur. So there's a slight difference here, which is I'm not looking at the key code. So basically what I'm doing is I'm enabling it so that if you click in, type something, let's say bleh, and then I click out, so that was the blur event, which is what this is handling. So this is saying when I blur out, so when I click outside of the input is the best way to think about it, I want to update the requirement. But also, when I have a key up event inside of the editing input where the key is 13 or the enter or return key, I also want to do an edit or an update to the requirement. And so if I change this and say enter key, we get the state change back and we get our edit. And then if I say click out or blur the input, we get the same exact thing. So let's take a look at handle update requirements. So again, we're passing in the event and the ID of the requirement that we're trying to edit. So this is where things get a little more interesting. So the very first thing you'll notice inside of this function is that we're calling to event.persist. And we're going to ignore that for just a second because that plays into something that we're going to do down here. So just ignore that for a brief second. But the second thing is very important. So you may have seen this before in other JavaScript code. So event.stopPropagation is preventing a default JavaScript behavior or browser behavior of telling events to bubble up in the DOM from wherever they occur. So quite literally, when I click on this, JavaScript by default is going to bubble that event back up through each successive parent until it can't go any further. Meaning that if I click on this, so we'll click on this one. So when I did that, by default, JavaScript's going to apply that click or call that onClick event handle on every parent successively up the stack. So this is known as bubbling. So if you think like a bubble in water bubbling up to the surface, that's what this event is doing. And so sometimes that's okay, and sometimes that's incredibly frustrating. So in this case, I need to disable it because I don't want the click to bubble back up. And if memory serves, the reason why I did that is because of the drag and drop here. Don't hold me to that, but basically, whenever you want to stop some unwanted behavior with the bubbling, you're going to use event stop propagation. So that's literally going to say, stop the event from bubbling past the element where the event actually occurred at. So that's one. Two is where we get into the actual work that we need to do to perform our update. So there's two things at play when it comes to requirements inside of commands. So like we've been talking about, requirements exist on state. So they're on this.state.requirements of the requirements component. And so that's one change that we need to make. But again, if we look here, I'm going to say just a bunch of numbers, hit return, and I'm going to refresh the page. And we're going to see that, okay, that persisted to the database. So even though it immediately updated on screen for the user, that was our state call, behind the scenes we're also going to persist that change to the database because why wouldn't you? So that's what's happening in this code here. So the first part, the state change, what we're doing is we're using the function version, and there's probably a proper name for this that I'm forgetting. Send your hate mail, I guess. But I call it the function version of setting state. So the difference here is that if I were to call set state normally, and like we actually did below, I would do something to the effect of requirements is equal to, some value, something like that. So I would just pass an object to this.setState. However, there's another version of this that allows us to pass a function. And the reason we want to use this is because we want to get access to the current value of requirements and make a change to it. So one of the grand rules of React state, so this is I'm trying to think like, does this apply to anything else? It probably does, but specifically to state, you never want to mutate state directly. You may have read that in the documentation or heard that in someone else's tutorial. And so what that means is literally we do not want to mutate the state value directly. So I can't do something like this without some negative consequences. So I can't do set this.state requirements like we would another variable directly. I have to go through this.setState. And so in this current situation, what we want to do is make a change to this requirements array that already exists on state. Or better said, we want to make a change to one element inside of that array. But because we want to do that, and because state is immutable, or it's supposed to be immutable, what we have to do is take the entire array, get the element out of that array that we want to make the change to, change that element in memory, meaning change that element as it exists in that array in memory, and then set that entire array back onto state. So basically we're saying, okay, take this from state, put it over here, and then we're going to get just that one out, change it, put it back in the array, and then we're going to take the whole array and put it back onto state. And so that's what this code is doing here. So the first thing is, this is the current value. So this is the nice thing about this function syntax for set state, is that we're past whatever the current value is. So we can take that, and this is a copy that we can actually mutate, so we don't have to worry about breaking anything. And that's my favorite part about this function style of using set state. So we take requirements in, so this is the current value before we've made any changes, and the very first thing we need to do is find the requirement in that list that we want to update. And the way that we know is that when we called handle update requirement, remember we passed the event as well as the ID of the requirement that we're trying to change. So we're telling ourselves, hey, we're changing this one, or we're trying to. So what we're going to do is use just a native JavaScript find on the requirements array, and we're going to say in that array, we want to find the requirement with an ID equal to the ID that we've passed in to handle update requirement. So that's step one. So hopefully, if all is going according to plan here, what we're going to get back from this is the entire requirement object as it exists inside of that array. So that's part one. Part two is the next line, 88, where we're saying requirement to update dot requirement equals. So what we're doing here is we're saying we want to set the value of the requirement key on the requirement to update object, so the requirement that we pulled out of that array. We want to set its current value to the same value as the input, so what we just typed into the input. Now that may be a little confusing, but keep in mind that we're not actually calling any of this code until the user either presses the enter key or blurs or clicks outside of the input. So you may be thinking like, good lord, that's kind of terrible performance and all that. It would be if we were directly calling handle update requirement on every keystroke, but in this case we're not. We're only doing it on blur and when they hit the enter key. And so this is relatively performant. So what we're doing is we're saying, okay, grab whatever that value is from the input and set it as the requirement property on that requirement object that we pulled out of the requirements array. And this is a good point to call out event.persist. So earlier I kind of skipped over this, but this is where it comes into play. So with React, when you're passing events around, you're not actually dealing with a native JavaScript event like the browser event. You're dealing with what's known as a synthetic event, which means it's just an event that's floating around in memory and controlled by React and the virtual DOM. And so React doesn't keep that event around any longer than it needs to. And so what I mean by that is technically if we look at this code, this function right here is creating a totally different scope inside of this function. So technically, if you want to get real geeky, even though it's technically not, this is kind of like a closure. So we're defining a function within a function. We're calling a function within a function. And so what's going on here is we've got event target value being called here, but by the time that our code has executed this line, we've entered a new scope, which means we no longer have access to the scope of this function. Technically we do. So you're probably like, wait a minute, doesn't the arrow function bump the value, this value up? And it's like, yes, it does. But with React, that does not happen with synthetic events. So synthetic events only exist at the parent context. So beyond that parent context, the event just goes gone. It doesn't exist anymore. And so in order to prevent that from happening, we have to tell React, hey, keep whatever event is being passed in here around or persist it. So don't get rid of it. And so what that allows us to do is reference that event inside of a nested function scope to say, okay, we want to reuse that event here and say, give us its value. So we don't want to just get rid of it, which is pretty nice. So with all of that said, at this point, because we've made this change here, what we've effectively done, even though it may not look like it, is we've changed this requirement as it exists inside of the requirements array in memory. So again, if you can imagine the entire array of requirements, so I think we've got 4 or 5 right now. So that entire array of 4 or 5 requirements still exists in memory. Now what we've done is we've reached into that array and pulled out the one that we want to change, changed it, and now we've put it back in the array. It doesn't look like that, but that's exactly what's happening behind the scenes or in the computer ones and zeros matrix land. So once all of that's done, what we do is we pop that modified array back onto state. So we're effectively overwriting state. And because we've only changed that one value, visually to the user, because we're setting state here, the virtual DOM's only going to update that one element because that's the only thing that changed. So visually, it looks like we've changed just that one thing, but technically behind the scenes, we've modified the entire array, even though it's just one element in the array. And that takes some thinking to get a hold of. So that's the big tough part. Now, the slightly easier part is, well, we said we have 2 requirements. So we need to edit the value on state so that the UX on the client looks smooth, but we also want to persist that value back to the database once the user has made their edit. And so we can see here the first argument that we're passing to this.setState is all of our logic to handle generating the state value, so requirements, and then you'll notice we also set editing to null. So whenever I make a change, so I say testing, blah, blah, so I've just cleared out this.state.editing. So because it's null, that means that back down here in our code, this is not going to match anything. And so for every single item, we're just going to render our span tag. So that's part 1. So that takes care of all the visual on-screen stuff for the user. But then part 2, you'll notice that the second argument I'm passing to setState is just a generic callback function. And this function is supported by setState natively. So setState allows you to call a callback function, after you've set state. So you're saying set state and then do all this. And so in this case, all of this is saying if this.props.onEdit. So now we're talking about the props of the requirements component that's wrapping this whole list. So if that requirements component has this.props.onEdit defined, call that function. So in this case, and let's see how efficiently I can find this in the code base. View card modal, there it is. So if we look here, onEdit is being passed another function. So now I'm inside of the view card modal component in command. So if I go to handle edit requirements, we'll notice that what's happening is I'm calling to a GraphQL mutation. So what I'm doing is I'm saying, okay, we want to take whatever the changes were from the requirements component and persist those onto the database or into the database. So we can see here we call edit requirements, which is a mutation I'm loading inside of this file. And I'm saying we want to grab this.requirements.state. So if we look, let's see if I can get back down to it. Yeah. So I'm saying set a ref on that component that allows me to call to it. So we've talked about this in previous videos. I think we actually did it in the very last Feature Friday. What I'm doing is I'm saying add a ref to that component. So a React ref that gives me a pointer to that component. And then what I'm saying is I want to reach into that component. So I'm saying this.requirements, so this gives me access to the component instance as it's rendered. So that's the ref, that's us pointing at the component. Now I'm saying reach into that component state and then grab the requirements value off of state. So that it's effectively the one we just modified. And then all I'm doing from there is just saying pass that up to the server, persist it, and then just as a good measure, I say make sure to refetch the card that we're changing the requirements on. So we're making sure that the Apollo cache is up to date with what's on the state of the requirements component. So those are technically 2 separate worlds. And just in case there's a refresh or the user clicks out of the modal and clicks back in, we want to make sure that everything stays exactly as they'd expect it. We don't get out of sync between our state value and our database value. So that's all that's doing. And then after that, that's it. So that pretty much does it. There's not really more beyond that you need to do. So like I said, it's pretty simple, but there are quite a few moving parts that you have to wrap your head around with this. So hopefully that walkthrough is helpful. I know that inline editing is a relatively popular, at least familiar feature in a lot of products. So it's a good one to have in your arsenal and a good thing to understand. So that's going to do it for this Feature Friday. As always, make sure to click the button down below to subscribe if you haven't already, and hit the bell just to the side of it to get notifications as soon as these are published. And please, if you haven't been doing so already, hit the like button on these videos if you do enjoy it, because that lets me know whether or not I'm talking about something interesting or I'm talking about a bunch of gibberish. So that's going to do it for me, folks. As always, if you have any questions, leave a comment below or send a tweet on Twitter to CLVRBGL. So I didn't get the Clever Beagle. I got squirreled out of it by a spammer, but CLVRBGL if you have any questions. So signing off for the HMS Beagle. I'll see you next week, folks. Real quick before you take off, folks, I want to tip you off to a little podcast that I've been working on with my buddy Alex Price for the past few months called Eye for Detail. And this podcast is all about building an indie product. So if you're building your own product and you're interested about what goes into it and just learning some general theory and philosophy and learning from two guys working on their own products, make sure to check it out. It's available on iTunes, Overcast, Pocket Cast, via RSS, and if you're a SoundCloud user, you can also jump over to SoundCloud and subscribe to get the latest episodes.